Hi, I am Dr. Latchoumy from the Department of Information Technology, B.S.Abdur Rahman Crescent Institute of Science and Technology, Chennai. I would like to take to you about the different types of linear data structures. In the last video, I talked about the introduction about the data structure. This session is about the different types of linear data structure. So these are the topics to be covered. The basic linear data structure is list ADT. Then how to implement list ADT, array implementation of list, then stack ADT, then array implementation of stack, then queue ADT, then different types of queue ADT like circular queue, then double-ended queue and priority queue. Before moving to the linear data structure, we would like to know what is the meaning for abstract data type with respect to data structure. So ADT is nothing but it has a data structure with its operations, the various operations. So it stores the data and allow the various operations of the data to access and even modify or change it. So ADT is nothing but is a mathematical model, the data structures with its relevant operations. So it is a collection of data and associated operations to manipulate to that data. So that is nothing but the abstract data type. So if it already we talked about a list, stack and queue or data structures, we also call it as abstract data type. So the examples for abstract data type are list ADT, that is list is also abstract data type, stack is also ADT and queue is also ADT, because these data structures are having its own operations. We will see in detail. Okay, the first linear data structure is called the list data structure. So it is nothing but store the data in sequential manner. This is a data structure, otherwise ADT. It is store the data in sequential order and access the data and manipulate the data with respect to the operations supported in list data type. If you take the list linear data structure, this is nothing but like your array. Okay, it is not a new concept, it is nothing but array declaration, like your array declaration. Say for example, here int a of 10, a is nothing but array, otherwise you can call it as list. So list of 10 numbers, 10 integer numbers, otherwise say list of 10 numbers, otherwise say array of 10 numbers. Okay, both are same actually, it is nothing but array. Array is nothing but is a static allocation of memory. Okay, during compilation time we are allocating the space for declaration with respect to this particular array. So totally 20 bytes allocated for this list or array, that is int a of 10. Okay, these are the some preliminaries with respect to list, that is size of the list you can say it is n. For example, int a of 10, 10 is the maximum number we can store with respect to this list. So this, what is the size? N is nothing but 10. Okay, equal to or less than 10, we can use the size of the array. The first element of the array, call it as A1, then these are the operations supported with respect to list ADT. We can insert the data in the list, we can delete the data from the list, we can display the current status of the list, and we can even search or find the data in the list. Then how to do these operations with respect to the index. Okay, index is nothing but, okay, by using the index we can locate the particular data with respect to the list. So because of these operations supported, the list is also called as ADT, that is abstract data type. The next ADT is called the stack. Okay, stack is also list, but it has only one restriction, that is we can perform the deletion and insertion with respect to only one end, that is with help of the top pointer we can do this. Okay, stack is follows the last in first out principle. Whatever the data you are inserting last, we can remove that particular data first, right? So these operations are with respect to stack ADT, that is push. Push is nothing but inserting data with respect to top pointer. Then pop, we can delete the data from the top of the stack. Then top is an operation is printing the topmost data with respect to the stack. Then make empty is also supported function. If you want to make the stack as an empty, you can use this particular function. And isEmpty operation is nothing but to check whether the stack is empty or not before deleting the data, okay, from the stack. Then isFull function or operation is used to check whether the stack is full or not before inserting the data or pushing the data into the stack. Then queue, the next ADT is called the queue ADT. Okay, like stack, a queue is also is one type of the list, right? But instead of one pointer, here we are having two pointers, a rear pointer and the front pointer. For inserting, we are inserting the data using the rear pointer, while deleting, we can delete the data from the queue using the front pointer. Okay, here queue is follows the first in first out principle. Whatever the data you want to insert, you can delete first. That is the meaning for FIFO principle. Then the operation supported with respect to QADT or NQ. NQ is inserting data at the front, whereas DQ is deleting the data from the NQ is inserting data at the rear, whereas DQ is deleting data from the front, whereas front operation is returning the first item from the list. Then display is used to display the current status of the queue. Then different types of the queue are circular queue. In circular queue, the rear pointer is connected to the front pointer with respect to the queue. In circular fashion, we are representing the queue, whereas priority queue is apart from the data, we are maintaining some priority values. Based on the priority value, we can delete the data from the queue. Then one more variation is called the DQ, that is called the double-ended queue. In double-ended queue, at both ends we can do both operations like inserting as well as the deleting. Then one more linear data structure is called the linked list. Okay, list is nothing but is array representation, whereas linked list is nothing but is a pointer representation. Otherwise, dynamically we can allocate the memory for storing the data. Okay, next we will see about different types of the operations with respect to lists. Okay, before going to different linear data structures operations, okay, we should know what are different types of implementation. Actually, we have two ways of implementation. Okay, one is array implementation, that is array implementation is the static allocation of memory with respect to the data, sequential data. That is called the more static. During the compilation time, we are allocating the spaces in memory for the particular data, whereas pointer representation is dynamic allocation of the memory. Okay, using linked list, we can implement the data structure. So we are implementing the data structures like your list, stack, all data structures either using array implementation using array or pointer implementation using linked list. Okay, next few session we will see about how to implement the linear data structures using array. Okay, next we will see about some menu driven program for implementing the linear data structure list ADT using array. Actually, this is the menu driven program using array. First we are declaring the header value files, then followed by the prototype. Okay, if you want to like to develop some menu driven program, this is a clear template for developing your program. So first we need to use all the header files, right, then followed by the function prototype. So like your variable, we can declare the functions also. Okay, for example, with respect to list, what are the different operations supported: insert, delete, search and display. So we need to declare what type of the function it is, what type of the return type, what are the arguments are supported. So like variables, we need to declare the functions, that is called the function prototype. Then followed by the variables are used in the program. Then you can start your main program. So in the main program, of course, the declaration part followed by the menu. Actually in menu, we are defining all the operations supported. For example, 1 for create, then 2 for delete, then search, insert and display and exit, then get the choice from the user. Then using switch case, we are going to call different operations supported. For example, case 1, you can call the create. If it is 2, if you user entered the choice as 2, you can call it as delete. Like that, you can use the switch case and different operations. Then within do while loop, you can put this switch case statement. In while statement contains the conditions. Okay, while true, you can execute these statements. If it is false, you can come out of the loop. Then end the main program. Okay, this is one model. Okay, actually your ADT, using ADT is the modularity of the particular implementation. So main is a separate module. Then after completing the main, we can move one operation by another operation. Okay, next we are defining the create operation. That is another separate module. So create. So create is you are reading the list of data. Okay, here Okay, B is declared as the list, so we are reading some amount of data in the list, that is the creation of the list. Then deletion operation with respect to list. You can get the position where you are going to delete the data from the list. Then by using shifting operation, you can after deleting, you can using the shift operation, you can get the current list status. This is a separate module. Then search module. Okay, search module, you can always search, starting this search with respect to the first data in the list till the match found, otherwise till the end of the list. This is search module. Then insert module. Okay, while inserting, we need some empty location. For that, we are applying some shifting operation to make the free space. Then after reading the data to be inserted, then you can insert at the free space. This is the insert operation. Separately you can define. That is the modularity. That is the menu driven or module program using modules. Then one more operation is called display. You are going to display the current status of the list. So this is the way you can write the program using modules. You can define each and every operation separately using module. So what is the advantage of using module is, for example, if any errors occurred while running a program, if any error is occurred in deletion operation, you can go to that particular module and correct the error, right? This particular error does not affect the other part of the program. That is the one important advantage of using modules. So always while writing the program for implementing any types of data structure, you can develop the menu driven program plus program using the modules. Okay, next we will see about what are the applications of list ADT or data structure. Okay, this is very important. You should know where you exactly apply this particular data structure in real time. The one example is to manage the financial account, then to maintain the Aadhaar card details of the people by the government, then list of product keeping with respect to supermarket, then how the computer system is managing the programs waiting in the computer for the process. Then of course the very basic applications like to maintain the student list details and the employee details with respect to the organization. So these are the some applications of list. Okay, next we'll see about the next linear data structure is called stack. I already explained what is stack, right? The stack is nothing but is a list, one type of the list, with the restriction that inserts and delete can be performed in only one position. Okay, namely that pointer is called the top. Of course, it follows the LIFO principle. These are the operations supported. We will see with respect to the program. So this is called the stack model. Okay, in stack model you are going to store the data one by one. Okay, by using top only one pointer, you can insert the data in the stack and delete the data from the stack. So these are the operations supported. You can create the stack. You can push or insert the data onto the stack using top pointer. You can delete or pop the data from the stack using the top pointer, then print the current status of the stack and read the top value. If you want to print only the topmost data, you can use the top operation. Then check whether this the last operation is very important, condition checking, otherwise a constraint. Okay, whenever you are inserting the data, okay, before inserting it, you can check whether the stack is full or not. This is very important operation. Before inserting, you can check whether your stack is full or not. If it is full, no need to insert, right? So like that, you can, while deleting the data, you can check whether your stack is empty or not. If it is empty, no need to delete it, otherwise you can go for the delete. So always while using implementing the data structures, we must use these two operations like checking the particular data structure is empty or not, right, and full or not. Okay, next we will see about the stack ADT is implemented using array. I already mentioned how you can develop the menu driven program. Okay, this is also menu driven program. Also the program with the modules or functions. Okay, modules or functions are nothing but the different operations you can define separately. Then we can easily manage. That's why always while writing the program, you can write the program with the functions or modules. Okay, here I already mentioned we need to declare all the header files, then followed by the declaration part, right? I think here the prototype is missing. That is also must. We need you are declaring the function prototype, followed by the variable declaration. Then we are defining the function by function. Here in this program, I defined the different operations like display, then push, then pop, followed by the main program, whereas we saw in the last list operations, the main followed by the different operations, because all are different functions, no, you can use in any order. Either you can define all the operations followed by the main, or main followed by the different operations. Okay, we will see one by one. Yeah, here the first module or operation is display. Okay, display is nothing but you can print or display the current content of the stack. A stack is also nothing but is like of the list, right? So simply you can declare like int s of 10 is nothing but array declaration. Okay, s of 10 is nothing but 10 data we can accommodate with respect to stack. Then push. Okay, push is operation is nothing but inserting the data to the stack, right? Yeah, I already mentioned while inserting you can check whether the stack is full or not. If it is full, no need to insert it. Otherwise, read the data to be inserted, then increment the top pointer to one position up, then push or inserting the item. Okay. Then what about the pop? Pop is before pop is a deletion operation, right? So while deleting, you can check whether the stack is empty or not. That is the conditional checking, right? This is very important because the stack is empty, no need to delete, right? So before we need to check whether it is empty or not. So if it is empty, no need to delete. Otherwise, you can delete. What is a delete? Is nothing but take the topmost data or remove the topmost data from the stack. So you are printing the deleted item s of top, right? Then after deleting, the size of the stack is decremented, so we need to move the pointer top from top to the next down, one location down. Okay, after defining all the operations, say display, push and pop, okay, then main program is also function, you can define separately. How to write the your menu driven program? You can within do while, right? Within do while you can put your switch cases, different operations. So just write start with the do, then get the different choices. We need to define different choices like push, pop and display, then get the choice from the user, then you can use switch case. Different cases are nothing but different operations supported by the stack editing. Okay, this is a way for writing the menu driven program. It's very simple. Next we see what are different applications of stack. Okay, actually stack editing is used for variety of applications in real time. The one application is called the infix into the postfix expression. Okay, generally we are having different types of the expression. I think all of we know the infix expression is known well. That is a plus b is the example for the infix. Infix is nothing but the operator in between the operands. So for example, a plus b, a b are operand, a plus is an operator. So how to represent the expression as a plus b? That is called the infix expression. Whereas your one more type is called the prefix. That is called the first operator followed by the operand. That is the plus a and b. Whereas postfix is operand followed by the operator a b plus. So if you want to convert your expression from infix to postfix, we are using this stack for conversion. Then one more application is called the evaluating. Okay, after converting it into postfix, if you want to evaluate and get the result, for all that also the stack is used for this type of the application. For example, a equal to 2 and b equal to 3, ab plus is the postfix expression. Then with respect to the using the stack, we can get the output as 5 after evaluating a plus b. That is also one application. One more application is constructing an expression tree. Using the expression the infix expression, we are going to construct a tree. That is one application. Then one important application is called the implementing the recursion. Okay, actually recursion is nothing but the function call itself, right? While calling the function again and again, the stack is mainly used for storing the addresses for continuation. Okay, so these are the few applications of the stack editing. Okay, next we will see about the next linear data structure, otherwise QADT. I already mentioned Q is also is a type of plus, but here the Q is having 2 pointers instead of 1 pointer in stack case. So here rear pointer is used to inserting the data at the end of the queue, whereas front pointer is deleting data from the front of the queue. Then it follows, yes, it's the FIFO principle. Otherwise, you can call it as FIFO list also. Yeah, these are different operations supported. You can create a queue, then you can check whether the queue is empty or not or full or not. Then you can add the item at the rear, that is end of the queue, and remove the item from the front using front. Then if you want to print or read the first data from the queue, you can use the front function. Of course, the print or display function is used to print or display the current status of the queue. Yeah, these are the here inserting operation. We can have some specific name, that is called the NQ. So NQ is nothing but inserting, right? But here with respect to QADT, you can call it as NQ. NQ operation is used to inserting the data at the end of the queue, whereas DQ is deleting the data from the front. Then front is returning the front data from the queue, whereas queue display is displaying the current queue status. Then queue empty is checking whether queue is empty or not, and queue fill is check whether the queue is full or not. I already mentioned these two functions are very, very important, right? Queue empty is while inserting the, for deleting the data from the queue, you can check whether the queue is empty or not, whereas while inserting, you can check whether the queue is full or not. So these are the operations supported with respect to QADT. These are the few basic operations like insert. Okay, these are steps with respect to insert, or these are steps with respect to delete. Yeah, this is nothing but the menu driven program using function using array implementation. Okay, this is a QADT or a queue program implementing queue data structures using array implementation. So what are different parts of the program? Like first you can declare all the header files, right? Then followed by the variable declaration, followed by the definition for each and every operation, including your main function. Here NQ is one function or operation is called the inserting the data to the queue, right? What is the basic operation of inserting? You can, for example, you just assume your queue is having 4 data. If that is, if you want to add 5th data, you can increment the rear pointer to 1 and you can get the element and increment, insert, right? Okay, these are steps involved in the NQ operation. Now what about DQ? You can read, you can take the first data from the queue and assign to, for example, here element variable. Then simply you can increment the front pointer by 1, f is equal to f1. Okay, then you can return the element you can taken from the first location from the queue, no, you can simply return it. That is called the DQ. So before deleting a DQ, you can check whether the queue is empty or not. Okay, it's very simple operation, checking whether queue is empty, or if it is not empty, you can read the data and simply increment the front pointer 1, because after removing, now your queue is containing only 3 data, right? The second data becomes the first data now. Then yeah, these are the 2 constraint functions, right? Queue full, you just check whether the queue is full or not, then queue is empty or not. Yeah, of course, queue display for displaying the current queue elements, then followed by the main program. Here main is also, I already mentioned, main is also like your function, one separate operational function. So you can define separately. So what are the statements that comes under the main? Do while. Within do while you can beginning you can define all the operation like choices, right? In 1 for insert, 2 for delete, then followed by the get the option from the user. Then you can simply use cases with respect to different operations, right? So here case 1 is nothing but NQ, you can inserting the data. Case 2 is nothing but you can deleting the data. Then N program, N main program. So actually this is a way to write the program using modules. It's very simple. You can define each and every operation separately. That is the modularity. Your program is using modularity. If you are using the modules or different functions, it's very easy to handle it. Okay, next we will see a few examples of QADT. In real, if you take the real time, we are waiting in the queue, for example, get the ticket in the ticket counter, right? Then jobs are waiting, more number of jobs are waiting in the printer queue for printing the document, right, or jobs. So jobs, for example, 5 jobs are waiting, then we can allow one job to another job to get the printout. Then of course one more important application is called the queuing theory, right? If you take the mathematics branch, right, is your queue is using in very much, right, is very important data structures with respect to the mathematics. Yeah, next we will see about what are the different types of the queue, right? So far we talked about only the general queue, right? The general queue contains the 2 pointers, front and rear, and next, we are having some variations of queue like your circular queue. The circular queue is nothing but the last rear pointer is connected to the front pointer of the what your queue to utilize the memory in an efficient manner. That is the main motive or objective or the need for the circular queue. You are going to connect the last part of the queue to the first part of the queue such that you can utilize the memory in an efficient manner. One more variation or variety is called the double-ended queue. Here double-ended queue is nothing but at both ends we can perform both operations, insert as well as the delete. And one more variety is called the priority queue. I already mentioned priority queue is nothing but apart from the actual data we are keeping some priority values. So based on the priority values we can delete the data from the queue. Here, this is the example for the priority queue or application of the priority queue. For example, the emergency room in a hospital. Okay, it assigns the patients with always the very critical patient, right, with priority numbers. The patient with the highest priority is treated first. This is very good application for the priority. This is all about the linear data structures. I think so far we have talked about the linear data structures. I hope you understood okay, these concepts. So in the next section we will see about what are different types of non-linear data structures. Thank you.